Hello everyone, good evening. Welcome back to the solutions for the AP Calculus free response questions. We're at the third question. These are the questions from the year 2024. Now all of the solutions are given to these problems on the AP Calculus website, but they have only given the solutions in a strict and short method. That is because they just want to show you the elements that they use for marking. Okay, now for those of you that are preparing, only that skeletal approach may not be enough, so we are creating these videos here for you so that you know how to approach the problem and then arrive at the sort of solution which is given on the website. All right, so the solution that is given there is just for guidance for marking of answers so that you know which steps carry how much marks. All right, but here we are going to learn about the solutions in general. How are we approaching the problem? If a problem is given in this fashion, how would you go about solving it, and so on. Okay, so again, as you have noticed in the question papers, the questions are usually of comprehension type. All right, so this says that the depth of seawater at a location can be modeled by a function h that satisfies that satisfies the differential equation, and a differential equation is given where ht is measured in feet and t is measured in hours after noon. Okay, so t equal to 0 means time is 12 noon. Okay, it is known that h of 0 equals to 4. Fine, at time t equals to 0, that means at 12 noon h is the depth of seawater at a particular location is 4 feet. All right, a portion of the slope field of the differential equation is provided. Sketch the solution curve y equal to ht through the point 0 comma 4. All right, so 0 comma 4 is a point on the y axis. You would have to sketch the solution curve. Now the response sheet to this particular question contains this image on that page. All right, so the only thing that you need to do is to start at 0 comma 4 and follow the slope field. Okay, now I'll not be copying the entire diagram, I'll just be marking it on the diagram itself because that portion of the diagram will be there on the particular page for the response. Okay, so you will have the same advantages that I have right now. So starting from 0 comma 4, now this is 0 comma 5, right? So 0 comma 4 will be here and they have marked it as well. All right, so you just need to follow the slope field. Okay, follow the slope field, smoothen it out, and that will be your solution. Okay, now since I'm drawing with a digital pen, my fingers wavered a bit, but make sure you smoothen it out. All right, drawing with a normal pencil or a pen would be much more easier. Anyway, do make sure that you are extending the curve till t equal to 5. Okay, that is very important in context of markings because some people might trace it and leave it at, let's say, t equal to 3. That is not desired. Okay, you would have to trace it till at least t equal to 4.5 because the axes are given up till t equal to 5 and then it continues. But why take the risk? Just extend it till the last force field dash. All right, to join all the dashes. This is just like the join the dots exercises that we had as a kid. Just make sure you join the correct dots and make sure that you are not including any of the dashes that are from the force field at 0,5 or 0,3. All right, make sure you follow it carefully. Okay, the next sections, the next sub parts are a bit more analytical. No more joining the dot games. So let us look into it. This says for 0 less than t less than 5, it can be shown that ht greater than 1. Fine, find the value of t for which 0 less than t less than 5 at which h has a critical point. Now we know how to calculate critical points, right? We set dh dt equals to 0, right? Which means I can copy it from here, right? Half of h minus 1 into cos t by 2 is equal to 0. This will be our equation to calculate the critical point. Now critical points are also known as saddle points, inflection points, turning points, etc. So make sure that you are aware of the terminology because it can vary year upon year. Okay, the person who has set the question or the board that has set this question this year has referred to this as a critical point. Next year they might refer to it as a turning point or an inflection point. All right, so please make sure that you are aware of all the different names for the same thing. Now here we have the product of three things to be equal to 0. We have half h minus 1 and cos t minus 2, right? Now half cannot be 0, that is a constant. It is given to you that for t less than 5, 0 to 5, ht is greater than 1. If ht is greater than 1, then h minus 1 will always be non-zero, right? Because It's a difference of something that is greater than 1 and 1. So it will be non-zero. Therefore, the only part that could be 0 is cos t by 2. So this implies cos t by 2 is 0 equal to cos pi by 2, right? Because cos pi by 2 is 0, which implies t equal to pi by cos inverse. Okay, make sure that when you are working this problem on the answer sheet, you're not cancelling the cos because it's not a product. All right, so t equal to pi is the inflection point. And now what do we have to check? We have to also show that whether this inflection point is a maxima, minima, or neither, right? Because inflection points could be either at the bottom of the trough or at the peak of the curve, right? It's a turning point, so it will be either turning upwards or it will be turning downwards. Now it will be neither in the case where it's a local maxima or minima, right? Because you can have a curve which goes up and then goes up again, but by a larger distance. So in that case, the first one will be a local maxima and the second one will be a global maxima, assuming that it does not turn upwards once again. All right, so we would have to check this, and the easiest way to check this is via the second derivative test. So let us do that. We have dh dt given. We can calculate d2h dt2. Now half will be constant outside, right? So I'll just have h minus 1. I'll differentiate cos t minus 2, which will give me minus sine t by 2 into half, right? And then I'll keep cos t by 2 constant and differentiate and get dh dt, right? I'm not taking the derivative of h to be 0 because h is a function of t. Now here at t equal to pi, cos pi by 2 is 0, right? So this portion will, okay, this brackets touch. Yeah, fine. So the second portion becomes 0 and the first portion becomes d2h, d2h dt2. That turns out to be minus half into h minus 1 sine pi by 2, which is 1, right? So this implies d2h dt2 is less than 0. Okay, so if the second derivative is negative, that means the point that we just checked was a maxima. All right, so this portion is clear. Now the third portion says we would have to solve it. Use the separation of variables to find the particular solution of the differential equation with the initial condition. Now this differential equation is quite easy, right? You just have to bring the variables to each one of their sides, separating the variables. The method is also given. You would just have to do the calculations. So let us do it. We have dh dt is equal to half into h minus 1 cos t by 2, right? Now I can bring h minus 1 to the denominator, which will give me dh by h minus 1 is equal to half cos t by 2 dt. Just separating the variables. Now I can perform the indefinite integral, right? And I'll get the integration constant, which I will eliminate via the initial condition given. So integration of dh by h minus 1 is equal to integration of half cos t by 2 dt, which will give me ln h minus 1 is equal to, now I'll get 2, actually I'll get sine t by 2 divided by half, right? And we had 1 half getting multiplied, so the halves will cancel and I'll get sine t by 2 plus c. Now you can put the initial condition h of 0 equals to 4, right? Now this is under modulus, right? Now remember the condition where it was said that h is greater than 1, so that modulus is as good as not being there. Alright, that is why I put the brackets initially, but I should tell you the reason for it also. Since it was given that h is greater than 1, the difference between h minus 1 will always be positive, right? So that modulus is going to be always positive and it will work as normal brackets. So h of 0 was given to be 4, right? So that means here I can put, I'll just write it as h of 0 equals to 4. I have 4 here, right? So ln 3 will be equal to sine 0 plus c, so c will be equal to ln 3. Okay, if c is equal to ln 3, I can just write the solution. Ln of h minus 1 will be equal to sine t by 2 plus 3, which means, okay, I'll just write it here. I will have ln h minus 1 equal to sine t by 2 plus ln 3. Okay, so this will give me, after I take it as an exponent, I'll get h minus 1 equal to, I'm just taking e to the power or exponential power on both sides, that will give me e to the power sine t by 2 plus ln 3. So that can be taken as a product, because if I have a to the power x plus y, that is basically a to the power x into a to the power y, right? So this can be written as 3 sine to the power t by 2. Sorry, 3 e to the power sine t by 2. And this will give me h equal to 1 plus 3 e to the power sine t by 2 as the solution of this particular equation. Okay, now this was a very small calculation. I'll just keep the screen here so that you can check the solution. Now what did we do here? We separated the variables, performed a simple indefinite integral. The condition was given, h of 0 equals to 4, and the modulus was removed because it was given earlier that h is greater than 1, right? If h is greater than 1, then modulus of h minus 1 is always greater than 0. If a modulus is greater than 0, it's as good as not keeping it, right? So we remove the modulus and we had e to the power, we have ln this side, so h minus 1 became e to the power sine t by 2 plus ln 3. Now I can separate this out, which means e to the power sine t by 2 into e to the power ln 3. E to the power ln 3 is just 3, so 3 sine 3 e to the power sine t by 2. All right, and the minus 1 there came to the right hand side, so I get h equal to 1 plus 3 e to the power sine t by 2. Okay, now just make sure that you separate out the variables and perform the indefinite integrals. Make sure you put the conditions, get the value of the constant, and then arrange it in a particular way. All right, as long as you get the value of the constant, it's fine. Okay, do not leave it at the point of the indefinite integral thinking that that is the solution. Okay, so it is stipulated in the solutions that you must find out the value of the integration constant, and that is the only reason why they have provided you with the initial conditions. Otherwise there was no reason, right? So the initial conditions are provided so that you calculate the value of c. Okay, as expected, the problem was not very difficult. It was a comprehension type question. There were a lot of information given to you so as to explain the context of the problem, but at the core of the problem the calculations were very easy. Okay, now if you do have any queries relating to these type of problems, or you want to refresh the basics of calculus, do make sure to contact the number that is given just below my face panel. You can drop a WhatsApp there, our team will get back to you. Alright, if you do have any suggestions, comments or feedback for this video, use the YouTube comment section. All the contact details and the course descriptions will be given in the YouTube descriptions as well, so you can use the contact details from there as well. Okay, do make sure that you contact us if you face any difficulty. We will be glad to help. Alright, I'll wrap this up here. We will meet again in the next video where we will discuss the next solution. Okay, bye, take care.